Welcome to the third and final video on Microsoft Excel. In this video, you'll learn about formulas and functions. Formulas and functions can get technical real quick. Let's ease into the topic with a non-technical example I hope will provide some motivation for what follows. Let's say you're planning to paint a room. This is an odd room because it has no doors or windows, but as you can imagine, I'm simplifying the problem. Anyway, you're getting ready to paint this room and want to know how much paint to buy. The room is 10 by 11 with 8-foot ceilings. Let's say a gallon of paint covers about 350 square feet. You need a formula to solve this very practical problem. The formula to calculate the square footage of wall space around a room is length plus width times 2 times height. Length plus width gets you the linear footage of 2 walls. Double it, the times 2, and you'll have the linear footage all the way around the room. Times the height gets you the square footage of wall space in the room. So let's plug in some numbers. For our room, the area or square footage is 11 plus 10 times 2 times 8, or 336 square feet. Note the parentheses are important. Look what happens when we leave them out and do the multiplication first. That is, if we do 10 times 2 times 8, which is 160, plus 11 is 171. Wrong answer. If you type this formula into Excel without the parentheses, Excel would do the multiplication before the addition, because multiplication takes precedence over addition. Precedence means is performed before. Without the parentheses, Excel would perform the multiplication before the addition, and you would get the wrong answer. In Excel, and most other tools for that matter, multiplication and division take precedence over addition and subtraction. In short, when in doubt, add parentheses. There's no harm in adding extra parentheses. Well, back to the correct computation. A gallon of paint covers about 350 square feet. So our formula tells us we should be able to paint the room with just 1 gallon of paint. Do you really want to go through all that work every time you want to paint a room? There is an easier way, and that way is to create a spreadsheet based on the formula. With such a spreadsheet, whenever you need to calculate the wall area of a room, you would just plug in the inputs, that is, the length, the width, and the height of the room. And we can even add a formula for calculating the number of cans of paint needed, given the coverage of the paint that we're interested in. Earlier, I estimated the coverage to be about 350 square feet per gallon, but some paints cover more and some cover less. Well, want to know more, because here is just such a spreadsheet. We have inputs for length, width, and height of the room. Notice the values of these cells are simply numbers. There is a formula here for calculating the square footage. B3 plus B4 times 2 times B5. We have an input for the number of square feet covered by a gallon of paint that we're interested in, and a formula for calculating the number of gallons needed. So that's the real power of spreadsheets. Calculations expressed as formulas. These formulas reference other cells in the spreadsheet. Change an input value, and the change automatically ripples through the spreadsheet. Here are all enter values for another room in the house. Remember, formulas are one of 3 data types that can be entered into a cell. The other 2 are text and numbers. This spreadsheet has all 3. Numbers for input, text for labels, and formulas for area and the number of cans of paint needed. So now that you're an expert with formulas, let's explore functions. These are 2 separate ideas, although the 2 are sometimes conflated. A function is a preset formula in Excel. Functions are just a convenience. Without functions, you would have to hand enter every formula that you needed. For example, in the first video, we used the PMT or payment function to calculate monthly payments from principal, interest rate, and term. And here's a simplified version of that worksheet. It tells us if we borrow $300 for 3 years at a 5% yearly interest rate and make yearly payments, we would owe $110.16 each year for 3 years. PMT is a built-in Excel function for calculating payments based on those 3 parameters that I just mentioned: interest rate, number of payments, and amount borrowed. And again, the PMT function is just a convenience. To the right here, I have the underlying formula that does the same thing. It uses the same inputs and gives the same result because it's doing the same calculation as the PMT function. It's much easier, of course, just to use the PMT function. So the moral of the story is, before you enter a complex formula like the one on the right here, you should first check to see if Excel already implements the formula as a function. To browse available functions, select a cell and go to the Formulas tab and select Insert Function. The function browser is convenient because it gives a short description of each function. Notice that most functions have parameters or arguments. The arguments are contained inside round brackets and separated by commas. For example, the arguments for the PMT function are rate, number of payments or period, and loan amount or present value. There are 2 additional arguments here for the payment function that you can ignore if you're just using the payment function to calculate payments. Now that you know what a function is, I'm going to show you how to enter one. I'm going to use the sum function to add the values in these 3 cells. Sum is probably the most used function in Excel. I'm going to enter the sum function in cell B3. If you know the name of a function you want, you can enter it directly. The other option is to browse for it. I'm going to use browsing because, at least in the beginning, this is probably what you'll use most often. As I mentioned before, to browse for a function, go to the Formulas tab and select Insert Function. Well, here's the sum function. Notice there's a short description that describes what it does. It looks like it takes 1 or more parameters. I'm going to select it. Up pops a convenient dialog box for entering the arguments or parameters for the function. For each one, I'm going to click back in the spreadsheet to specify the argument. And now I'll click OK to enter the function. There. We have a sum function with 3 arguments. I could have typed it directly, but it was just as easy to use the dialog box. Functions such as sum are often used with range references rather than individual cell references. A range reference is 2 or more contiguous cells. For example, rather than 3 cells in a row here, what if we had 30 we wanted to sum? It would be pretty inconvenient entering 30 parameters. Instead, you can use a range reference. Let me demonstrate. I'll delete the current arguments and enter a range reference specifying the cells in the range from A1 to C1. There. This is a nice example of using the sum function with a range reference. Before I go on, I want to mention a more convenient way of entering a range reference. Rather than type A1:C1, you can click and drag across cells to specify a range reference. Let me demonstrate. I'm going to delete the current range reference and specify it again by clicking and dragging. There, same result, but somewhat more convenient to enter. I've been using functions all alone as the cell value. A function can also be used as one argument in a larger formula. For example, I'll compute the average here by dividing the sum by 3. This is just for demonstration purposes. You wouldn't actually use the sum function to compute average because there is an average function which does it for you. Here, I'll enter the average function below, just as another example of using functions. So to summarize formulas and functions, a formula performs mathematical operations to produce a result. A function is a predefined formula. Formulas may include functions. Here I have the formula sum divided by 3. The result of the sum function is just one argument in the formula. Next, I want to discuss some of the more common features used in conjunction with formulas and functions. First up, fill. Fill can be used to copy the contents of a cell to adjacent cells. To copy using fill, select the cell or cells, hover the mouse over this small box in the lower right-hand corner until the cursor turns into a plus sign, then click and drag. This small box in the lower right-hand corner is called the fill handle. Fill works with string values as well as numbers, and you can fill across as well as down. The real value of fill comes into play when copying formulas. I'll add a formula here for calculating pay, which is hours worked times pay rate. The formula is going to be slightly different for each row. For the first row, it was B9 times C9. For the second row, it'll be B10 times C10, and so on. It'd be a real bummer if we had to retype this formula for each row, but we don't. We can use fill to copy it down. Fill is smart about how it handles cell references. Notice that when I use fill to copy down the formula, the references inside the formula change accordingly. The references in the copied formula are relative to what they were in the original. The references in this formula are called relative references because they change relative to the original values. Move the formula down 3 cells, and row references in the formula will advance by 3. Move the formula to the right 3 cells, and column references will advance by 3. This type of behavior is what we want for this example, but sometimes you don't want cell references to change. Through the magic of video editing, let's modify this example slightly. In this new example, assume pay is defined as some base pay plus hours worked times pay rate. I'll enter the formula for that. Well, that formula works well for this first line. However, if I fill this formula down, I'm going to get erroneous results for the other lines. Notice how C6 changes from C6 to C7 as I copy down one line. Excel doesn't know that I want C6 to stay the same, but the others to advance as I copy or fill down. This brings up the idea of relative versus absolute references. Right now, all the references in this formula are relative. When copied down, the values will change relative to the distance copied. I can make C6 an absolute reference by adding $signs. Let's copy this formula down. Well, that looks better. $C, $6 tells Excel to not change the reference when copying the formula down. The $sign in front of the column letter keeps the column reference from changing. The $sign in front of the row number keeps the row number from changing. So if you don't want a reference to change when copying a formula, add $signs to make it an absolute reference. I'm going to end with a demonstration of a few of the more common functions used in Excel. I think it'll reinforce a few of the ideas we just discussed. Let's say I want to compute the minimum, maximum, an average of the 4 values in this pay column. I'm going to pretend I don't remember the name of the function used to find the minimum value in a range of cells. So I'm going to go to the Insert Function dialog box. I'll enter the word minimum in the search area. Browsing through the options, I find min. It looks like what I want, so I'm going to select it. I'll enter the range of cells by clicking and dragging. There, the function correctly found the minimum value in the range. I'm going to assume that there's a corresponding max function, so I'll enter it directly. Looks good. And now I'll enter the average function. Well, that concludes the third and final video on Excel. Now it's your turn. If you have access to Excel, open it right now and try some of the features we just discussed.